Hello guys, welcome back. And again, today we cover the 5C, exponential equations. Like last video, we gave some basic definition for exponential functions, and for the oldest number, which is e is just like 2.718, okay? Or you can just remember it's 2.7 something, it's enough. So for today, we're gonna cover 5C for exponential equations, or basically like index laws, okay? To refresh your guys' memory and to do more calculations, okay? So the first one is this one. It's pretty straightforward, but it is important, okay? A to the power of x equal a to the power of y implies x equal y. So what's the type of problem gonna look like in this way? Example 8, okay? So we always, for this type of questions, we need to change to the same base. Same base in this case means you can change to 256 or you can change to 4. But of course, we change to the smaller one is slightly easier, okay? Because this one is 4 to the power of 4 and this one is 3 to the power of 4. So we can get x values by just equating the power, okay? And for these 8 important equations or theorems or formulas, whatever you want to call them, you have to be really, really confident about it, okay? So the first one and the third one sometimes can trick people a lot, okay? And this one is also important. And the last one, a to the power of 0, just like 1, okay? So in this case, again, for example 9, change to the same base, okay? But for this one, it's two ways. You can change to 25 as what they did in example 9, but you also can change 5 to 25 because you can do 5 squared x minus 2 equal to 25 negative x plus 2. So left hand side becomes 25 x minus 2 equals 25 negative x plus 2. So x minus 2 equals negative x plus 2. So which means 2x equals 4. So again, my x is going to be 2. Okay, so there's multiple ways to do the same questions. Just choose the way you like. But our essential method or the significant part is always change to the same base. Okay. Let's keep going. Okay, this is the tricky part I want to emphasize here and here. Okay, let's look at them one by one at a time. So first one is, if we look at here, like, okay, 9 to the power of x. And the right hand side, 3 to the power of x. Okay, again, change to same base, right? This is what we always thinking. So change to the base, like what they did over here. For this one, you're done 50%, actually, if you can change to the same base. But then some people or some students going to be stuck here. He or she will say, sir, it's like what to do next. And this is pretty important connection you need to build, okay, with our exponential functions and our polynomial functions. Essentially, in this case, is quadratic or parabola, okay? So in this case, again, we use like substitution method. We make y equal to the 3 to the power of x, right? Suddenly the equation becomes y squared equal to 12y minus 27. Then we rearrange the equation to get this guy. Then what do we do? Cross product, right? Just make sure if this type of questions appears in exam 1, the numbers is always nice, so you always can do the cross product to get easy and nice numbers, okay? So in this case, I got y equals 3 and y equals 9. And then it essentially means 3 to the power of x equals 3, or 3 to the power of x equals 3 squared. So my x value will be 1 and 2, okay? Let's go through this idea again. First, essential idea, change it to the same base. Then by inspection, saying, okay, this is can be treated as the quadratic equations, okay? So sometimes for here to here, it's actually one skip since because 9 to the power of x, first is 3 square for the x, right? Then we switch these two things, 3x square. So it's essentially the same thing because both of them equal to 2x, right? 3 to the power of 2x. And after we done this one, we move on to the next one, b. B looks like easier, right? Because they already help us to change it to the 3 to the power of 2x, right? Again, we use the same thing, y equals 3 to the power of x. Then we get this one, right? Again, we use our cross product to get this one. Okay, suddenly you realize this time 3x equals 3 or 3x equals -9. So hopefully you guys still remember exponential function, the range is always greater than or greater than 0, right? For the normal one, okay, not with the transformations one. That means 3 to the x equals -9 cannot exist. You cannot find any x values to satisfy these types of equations. Make sense? Because 3 to the power of x can look like this. Okay, this is x, this is y. So we always beyond the x-axis. So essentially it means we cannot really get anyone below or lower than 0. So this is the tricky part. For me, if you like to use the substitution method, my suggestion here is you can make, okay, y equal to 3 of x, then you directly write greater than 0 at the end to emphasize or to remind you guys the y must be a number greater than 0. Otherwise, it's impossible to solve for the original one, which is 3 to the power of x, right? Hence, our final answer is only one solution. Okay, that's gonna ring the bell. Ring the bell for the final exam. In final exam, if they give us these types of problems, we get 2 answers just to make sure, always double check. So you might have to eliminate one, or you might can keep both, but always one thing we called checking. Okay, always check the things you did. Okay, always. And this is the section summary for 5C. Again, we use substitution method, and our essential first step is change to the same base. Okay, same base. Okay, and let's look at some questions. In here, for simplify the following expressions, this one is pretty important because you can use this one to training your understanding or training your basic calculations with the index laws we just mentioned slightly earlier. For instance, over here, you can look at x to the power of 0 just like 1, so it's 4 to the power of 2 is just like 16. Makes sense? And we just keep going. For this 2, just need to change to the base, same base to get the idea, okay? For 3 and 4, it's just emphasize my point being made before. Like change to the same base, then you can use the substitution, then you can get the answers, okay? So in in the question 4, this is pretty nice. They help you bracket them. But for our final exam, the question will look like this one: 9x minus 2 times 3 to the power of x plus 3 equals 0. So first, they won't give you the brackets to emphasize this point. And again, they won't give you to the 3 to the power of 2x. They will give you like the 9x to even trick you more. Okay, but you always need to change back to this type of form, same base but different power, then use the hyperbola. Sorry, then use the parabola or the quadratic equations to help us to solve. Then after that, checking. Okay, so until now, we've done the exponential functions with graphs and with calculations. For our next videos, we're gonna start to do the 5D, okay, which we call it logarithms. Okay, and I hope you guys enjoy this video, and if you think it helpful and you like it, please click the like button and subscribe my channel. Okay guys, that's end of the day. Thank you for watching. Thanks for watching. Bye bye guys.